Bismillahirrahmanirrahim. Assalamu alaikum and good morning, my students. As you know, we were doing in our last session quadrilaterals, and we have discussed the properties of quadrilaterals. And the last property, which I forget, is that what are the angles between the quadrilaterals. Now, if I draw a picture, now, dear students, this is a rectangle, and if I make a diagonal in between the two corners, what will happen? You see that now, you see, my dear students, now this rectangle has been divided into two triangles. Now, what are the triangles? Now, this one is the triangle and this one is the triangle, and you know that there are, now this is triangle, this whole triangle, now this whole triangle is A and this whole triangle is B. As we have stated that in a triangle there are how many angles? The sum of the interior angles of the triangle are 180 degree. Okay. Now A is equal to 180 degree, the interior, this one, and this one. And again the B, this one, this one contains 180 degree angles. Now what happens if I both add them up? It will give us 360 degree. Now this was the one way to tell you that how many angle does a quadrilateral contain in its interior angles. So if I don't do it like this, in this way, just move this line. Now you see that in the rectangle there are 90 degree angle, 90 degree angle, 90 degree angle, and 90 degree angle. So 90 plus 90, 180, and 180 plus 180 degrees again becomes 360. There are many ways to find that in quadrilateral there are 360 degree. Now this is very important property of the quadrilateral, and we can find the unknown angles with the help of given angles by this property. So let's proceed to the exercise. Instead of doing the worked example, I have seen the worked example. They are very simple and very easy. So I am going to skip them. Or let me do one work example out of three. Now this is a figure. It is a very irregular figure given to you. To find this angle x over here, the only thing in this triangle, in this part, is given that these two sides are equal. When these two sides are equal, that means their base angles are equal. Now this base angle is equal to this angle. So see what happens, and these three angles are also given. Now this is 70 degree, 145 degree, and this is 80 degree. We can easily find this angle over here. We can easily find this angle over here because I have just told you that the sum of angles of the quadrilateral are equal to 360 degree. That means this angle L, this is angle L, this is angle M, this is angle N, and this is angle K. I have written in small alphabets rather to uh, write the full angle. Now what will happen that C plus M plus N plus K. Now C plus M plus N plus K will be equal to. So dear students, this quadrilateral is given and we have to find this angle X. The clues which were given are 70 degree, 145 degree, 80 degree, and these two short lines, which means that this triangle k x and y is an isosceles triangle. Since this is an isosceles triangle over here, then these two base angles must be equal. Now, to start, I have written the respective angle in smaller alphabets: L, M smaller, N smaller angle, and K. Now, what does it mean that angle C, M, N, A should be equal to 360 degree? Now, angle C, M, N, K, L. Angle LMNK is equal to 360 degree. Now, three of the four are given: 70, 145, 80. Let me write all which are given. Now, this is given, 145 plus N is given also, but K is not given. So, that is equal to 360 degree. We'll add these up. This is equal to 150. 150 plus 150 gives us 300, but this is less 5, so it is 295. 295 plus k, simple algebraic calculation, is equal to 360. Now k is equal to 360 minus 295. Okay, now k is equal to 65 degree. K is equal to 65 degree. It is very simple. Now this k is equal to 65 degree. So when this k is equal to 65 degree, naturally this k is also equal to 65 degree. Now this is angle x. No, I cannot write it x because x is already given. So this angle, this base angle, due to this isosceles triangle. Now this is an isosceles triangle. Which one is isosceles triangle? KXY. Now KXY is equal to isosceles triangle, which is given. Now this is given. You can write the reason that this is given. KXY is an isosceles triangle and it is given. The base angle must be equal. Now if it is K, and let me give it another name, Z, let me give it Z, small z. So K and Z must be equal. When these are equal, then I don't need to write it as Z. So I will write it as K again, because it is an isosceles triangle. So when K is equal to K, then what will happen over here? That 2K plus X is equal to 180 degree. Now since K is 65 degree, now 65 degree, just do it in this way, plus X is equal to 180 degree. So it will become 130 plus X is equal to 180. So X is equal to, shift this over here, eliminate it from here, it will become 50 degree. So this X is equal to 50 degree. We have come to know by the clues given to us, which were that this is an isosceles triangle, and we have used the property, and you can write here the interior angle of quadrilateral is equal to 360 degree. Interior angles of quadrilateral is equal to 360 degree. So it was very easy, my dear. Well, students, proceeding to exercise 3.6, we have already done one of the three worked example, and I told you that only one was a little tricky question in worked example. Therefore, I skipped the other two. So, question exercise 3.3, question number one. It is written before you. Now, let me read it for you. A quadrilateral has two diagonals. Yes, every quadrilateral has two diagonals. It is very obvious which intersect each other at right angle. Now, some of the English words are skipped, and I have written some short. You will see all English sentence in your book. A quadrilateral had two diagonals which intersect each other at right angle. Okay. Now, what could it be? What quadrilateral could it be? Is the first of the two. Now, you can see that in our uh, previous lecture, that I told you that the right angles. Now, the right angles are only formed when the quadrilateral is a square. That means all the sides are equal. All the sides are equal, and if we draw diagonals, to it, then all the diagonals you will see that will bring 90-degree angles to them. Now, this is one figure, and it satisfies this statement. It satisfies this statement. What quadrilateral could it be? But it is not only the one. It is number one. The number one answer is square. Okay. Is there any other? Yes. If I press this, what will it become? It will become a rhombus. The same figure is rhombus. If I press it towards one side, this was square and this is rhombus. And when you make again the diagonals, it will be 90 degree. When one is 90 degree, ultimately the second one should also be 90 degree. So all the four are 90 degree. So I can write here as rhombus also. There is still one left, and that is number 3. Now I'll make the figure again, and this is your favorite thing, a kite. And if I join the diagonals, you see that these also intersect at 90 degree. This is very rough, but even then you can see that this is 90 degree in each case. Square, which I erased, rhombus, this is rhombus, and this is kite. So sphere, rhombus, and kite are the three figures, three shapes which could contain this property. A quadrilateral had two which intersect each other at 90 degree. What quadrilateral could it be? So these three are the answer for the first one. Now for the B, the diagonals are not equal in length. The diagonals are not equal in length. What? the quadrilateral couldn't be. Now, the diagonals are not equal in length. What quadrilateral it couldn't be? So it is very, uh, again, a very simple question. Now, the diagonals are not equal in length. Not equal in length. What quadrilateral couldn't be? Now, if I make this one, now these are equal in length. These are equal in length, and it is the square. And square is the only answer for this when diagonals are equal. So it has asked us, it has asked the diagonals are not equal in length. So diagonals are equal in length. So the could not be word is used here. So the answer for the B is only a square, because uh, it is it is a quadrilateral which has two diagonals which are equal. So the answer is square. Now let us find some. Now let us find some unknown angle with the help of uh, known angles using the properties of quadrilateral. Question number one. In fact, question number two, part A. This is question number two, part A. I have drawn a shape in front of you, and some clues are given. When arrowhead, you see the arrowhead, you just infer that these are the parallel lines. These two are the parallel lines. Now, if it is one and here it is one, then it means that these two are the parallel lines. And for one short line, that means the lines are also equal in length. This PQ is equal to SR, and PQ is also parallel to SR. Now I'll make two arrowheads. That means that this PS is also parallel to QR, and two short lines means that PS is also equal in length with QR. Now, this was the small uh, description of this question, part A. Now, what the angle is asked is this one. Okay, we have already studied in our definitions and of the properties of the parallelogram that the opposite angles are equal. The opposite angles are equal. Now you see that 100 now in these questions you have to give the reasons also, the arguments also. Now you see this is 112 degree. This is outer angle is 100. There are other ways to prove this or to find this angle, but the simplest I am going to do is that this angle is equal to this angle and this angle is equal to this angle. This is written in the properties, and I have told you that this is the property that the opposite of the parallelogram, opposite angles are equal. Okay, if this is x, this must be x. If this is y, this must be y. This is the property of a parallelogram. Now you see that this is 112 degree, then this must also be 112 degree, cause you see that this section here is opposite angle, vertically opposite angles. When two lines cut each other or bisect each other or intersect each other at one point, the opposite angles are equal. The opposite angles are equal. So this using this property, the opposite angle are equal. So this is 112. Ultimately, the x is 112 degree. using this property, let me say it y is equal to 112 degree. When it is 112 degree, it means it is vertically opposite angle. Vertically opposite angle. Vertically opposite angle, then this angle is equal to this, and this is the property. X is equal to y. Because x is equal to y, it is property. Okay, now this has been solved. Now question number 2, part B. Now let me find the what are the clues given to it. Now the this angle is given, and this is 62 degree, and this is asked, and this angle is asked over here. So my dear students, it is very easy. I told you that in a rectangle ABCD, or whatsoever the rectangle is, all the four angles are 90 degree. This was the unique property of the parallelogram. This was the unique property of the parallelogram, because in every parallelogram there are not 90 degree, but there is one parallelogram, as I told you, that was rectangle, which has all the angle equal to 90 degree. Now there is a property of this uh, rectangle ABCD. Now you see that this triangle ABCDE. Now this is E. EBC, triangle ABC is an isosceles triangle. We are using the properties of a rectangle. So if this is EBC is an isosceles triangle, then these are the base angles. These are the base angles. The base angles are always equal in length. So 62x is equal to 62 degree due to this reason. Base angles. You can also write it as base angles.